Okay, so here we have some questions that I received in the order that I'm going to answer them. So if you want to go straight to the problem number, you can fast forward to those if you want. Okay, so let's start with 30 through 38, and then go ahead and scroll to whatever you need if you don't need these first. All right, so 30 is 135 degrees. I have an older book, so this is not the same problem in my book. I'm going off what I've received from some of you, so I'm hoping this is the right problem. And you're supposed to give two positive and two negative coterminal values. So visually, we're at 135 degrees, which is right there. It's a 45-degree reference angle. So what you do is you need to go around positive wise. So we go this direction. There's 135. And then we do another 2 pi. In this case, we're looking at degrees. So that means we're going to add 360 degrees to get back to that. So add 360 to 135. And we get 495 degrees. All right, and then we take that and we go around again 360 degrees, and we get our second positive angle. Okay, and then from 135 degrees, if we go backwards 360 degrees, so here we're going to take 135 minus 360, and that should give us negative 225 degrees. And take that negative 225 degrees and subtract 360 from that. And let's see, we get negative 585. So there's a couple different ways you could go about doing this, but that's what you're doing. You're going around and around 2 times. Once and then a second time, both in a positive direction and then in a negative direction. So as you get to your pi values, so on 32, I'll just do 32 on this same one here, we have 11 pi over 6. So 11 pi over 6 is right there at 330 degrees, except we're not going to use degrees. We're going to use the radian measurement of 11 pi over 6. So just like up above on number 30, we're going to add 360 degrees, except we're going to leave it in terms of pi. And 360 degrees is the same as 2 pi. Now we need to get a common denominator, so we multiply by 6, and we get 12 pi over 6 plus 11 pi over 6, and that gives us 23 pi over 6. And then again, you need to take that value and add another 2 pi to it. And we already know what that is. That's 12 pi over 6. And we add that together and you get 35 pi over 6. So those are your positive values going around in a positive direction. Now we need to go negative. So we take the 11 pi over 6 and we subtract 2 pi. So I'm going to leave it as 12 pi over 6. That's the same as 2 pi. All right. And what do we get? 11 minus 12 is negative 1 pi over 6. So you have a negative 1 pi over 6. And again, we subtract 12 pi over 6. That's 2 pi. And we get a negative 13 pi over 6. So there's your 2 negative and your 2 positives for 30 and 32. Okay, I'm not going to do 34, 36, and 38. If you want to see those, you can ask me tomorrow during class, and I'll go back over those. But let's go ahead and go to number 64. And let's take a look at that. Okay, on 64, I think I've matched it up with the one in my book. Again, if not, I'll answer tomorrow. Let's see, this is 0.7 radians. And the area of the sector is 12, so that's the area, and the radian measurement is 0.7 radians. All right, so that's this distance here. So the area of the sector of a circle is 1/2 the radius squared times theta. And the key here is that theta needs to be in terms of radians. And we actually have radians. In general, it'll give you theta, meaning the degree. And you'd have to take that times, whatever that degree is, times pi over 180 to turn it into radian measurement. But we already have the radian measurement of 0.7 radians. So the area of this sector is 1/2 the radius squared, which we do not have, okay? And theta is 0.7 radians. The area they did give us is 12. So let me rewrite this. 12 equals 1/2 the radius squared times 0.7 radians. Okay, so now we have everything in the right position. Let's solve it. Let's divide. Let's take half of 0.7. Okay, so that is going to be 0.35. Let me rewrite. 12 equals 0.35 times the radius squared. Divide off the 0.35. So 12 divided by 0.35 is going to be some ugly thing. Let me just check something real quick. And we get r squared is equal to 34.2857. And we take the square root at that point. And r, the radius, is going to be 5.8554. And I'm not sure, it doesn't really say what to round it to, so we'll just leave it as that at the moment. And there are no units yet for this, so we'll just say units. Okay, so that's number 64, all right? Okay, so let's get ready for 68, 69, and 70. I see I forgot something on 64, if I'm reading this right. We have 150 degrees here, and we know the area is still 12. In this case, so 12 equals 1/2 the radius squared times theta, and in this respect you have 150 degrees, which you need to change into radian measurement. That's your theta. So 150 divided by 180, we can reduce both those by 10 and we get 15 over 18. I'm just doing some quick reducing here. Reduce both those by 3 and we get 5, 6. So 12 equals 1/2 r squared. And here we have 5 pi over 6. Okay, so we're trying to find the radius again. So if we multiply by 2, I'll do it a little bit differently here. Multiply by 2 and we get 24 equals r squared, 5 pi over 6. And if we multiply by 6 on both sides, 6 times 24 is 144. And we have 5 pi left over. And we divide off the 5. So 144 divided by 5 is 28.8. And that's equal to r squared times pi. So now we divide by pi. Divide that by the actual number pi. And I get 9.16732, and that's equal to r squared. Take the square root of that, and 3.0278 is r. Okay, now we get to 69. Okay, I think this is supposed to be 68. And from what I can tell by some of the papers that have been turned in, our theta is 5 pi over 12, and the area is 20 meters squared. So if we think about your circle, 5 pi over 12 is going to give you, if you take 5 times 180, I'm doing this real quick on the calculator, divided by 12, you're going to get 75 degrees. So if we do this, we're talking about an area of a circle that's kind of like that. So that area is 20 meters squared. Theta is 5 pi over 12. So area of the sector of a circle is equal to 1/2 the radius squared times theta. Well, we already have theta. We don't have to convert it, and we already have the area. So we just plug everything in and then solve for your radius. Okay, so multiply by 2, and we get 40 equals r squared times 5 pi over 12. And we can multiply by 12, or just multiply by the reciprocal, 12 over 5 pi. And you work that out, 12 times 40, 480. Divided by whatever 5 times pi is, 5 times 3.14. So 480 divided by 5 pi on my calculator is going to be 30.5577. And you take the square root of that. And you get the radius to be 5.528. Okay, and since I can't figure out what 70 and 84 are in my book, I'll have to answer those during class tomorrow, which I have a feeling I'm going to have quite a few questions. So we'll see how that goes, and I'll try to make sure I get a picture of the book at some point in time if we're not here tomorrow. And that way I'll go through and give you some better explanations of those things. But it looks like from the people who've turned in their homework, there's a pretty good feel for this. So good job. Hopefully you'll see you tomorrow.